Okay, today we are going to learn how to find all the zeros of a polynomial equation without using the calculator, and then tomorrow we will bring the calculator back in and use that. So anytime it references using the graphing calculator, we're going to hold off on that. So the first thing you always want to do is see if you can factor, because factoring will be the easiest way to find your zeros. If you can't factor, you're going to do something called listing all the possible rational roots or zeros, and you're going to test these using synthetic division to see if you have a remainder of 0. So I'll kind of give you some examples of that in just a minute. Now, as I said, tomorrow you can use a graphing calculator, and then you can find some roots that way. So that'll be added tomorrow. So if you can determine that you have a rational root, you can actually do what's called synthetic division to use the polynomial. So basically, you're going to try to take the polynomial of a higher degree all the way down to a degree of 2 in this step. And then you would continue seeing if you could factor, and then if you can't factor, you might have to do quadratic formula, something to that effect. So I'm going to do some examples with you. You have a handout, so if you would, just flip to the back of the handout that looks like this. So I'm going to start with what is called the rational root theorem. The rational root theorem. The rational root theorem says that if you have a polynomial and it's in the form 2x squared plus 3x plus 5, that you can list every possible rational root by looking at all the factors of your constant over all the factors of your Lie coefficient. So for this example, the possible rational roots would be, of course, we have 1 and 5, and we have 1 and 2. So we call this P over Q very often, and P would be all the factors of your constant, Q would be all the factors of your Lie coefficient. So I have a 1 and a 5 for my constants factors, and I have a 1 and a 2 for my Lie coefficients factors. Then what I do is I basically mix and match. So I could have 1 over 1, and all of these could be a positive or negative version of the possible root. So I have a 1 over 1, and then I have a 1 over 2. I have a 5 over 1, and a 5 over 2. And sometimes you get repeats, and then you would not write them because they'd be redundant if you got the same thing twice. So how is this going to help us? So I'm going to give you an example and just kind of show you how this works. So I have a polynomial function, and it is f of x is equal to x cubed minus x squared minus 8x plus 12. Now when you look at this, you see that that's not going to factor. A lot of these will not factor. So if it won't factor, you're going to have to list your possible rational roots. And remember, we're doing this without the calculator today. So our possible rational roots, and the word possible is very important. We don't know that these are roots. We have to test them. So I have a plus and a minus, and then I have 1, 2, 3, 4, 6, and 12. And those are all the factors of my constant, so that's basically like my P. And all the factors of my Lie coefficient, that's just a 1. So in this case, it's just all the constant factors over the number 1. So it's just all these numbers, but positive and negative versions of that. Okay, so what are we going to do? Like, how is this going to help us? So I'm going to start. I'm just going to get the first one. I'm going to positive 1, and I'm going to set up synthetic division. So remember that you would have a 1. These are all of your coefficients. A 1, and negative 1, and negative 8, and a 12. Remember, you bring down your 1 to get started. Multiply, you add, you get 0. Multiply, you get 0. Add, you get negative 8. Multiply, you get negative 8 here, and you get a 4. My remainder is 4. And when that happens, I know that 1 is not is not a rational root of this particular polynomial. So I know this is not one of my roots. So let's try the number 2, just kind of going in order. So let's do 2. So I'm going to start by just bringing down the 1. I get a 2 here. When I add these, I get 1. Multiply, I get 2. I get negative 6. Multiply, I get negative 12. And here I get a 0. So my remainder is a 0. That means, and we've talked about this a lot, that means that this is really a factor. Remember, this was x cubed, so this would be x squared plus 1x minus 6. This is something that I can look at more. I can see if it factors. If it doesn't factor, I will use the quadratic formula. Sometimes I can use square roots to solve, but you've got it down to a quadratic, which you guys are familiar with. So this one actually will factor a little bit more. So I'm looking for factors of negative 6 that add, and this equals 0 is just for me to solve it. This remainder of 0 is what is telling me that 2 is a root. And we've also talked about this a lot. That means x minus 2 is a factor. And I kind of ran out of space here. All right, so when this factors, it would be x plus 3, x minus 2. So my roots would be a negative 3 and a positive 2. So all of my roots are 2, negative 3, and 2. Oh, well, that's interesting. I see that I have 2 here twice. So guess what that means? That means that I have even multiplicity. So this polynomial in factored form would be written as x minus 2 squared and then x plus 3. So there it is in factored form, and we can see the roots there. So we have found all 3 roots. So it's kind of bringing everything that we've been doing into play. So basically what I want to show you is if you have a polynomial and you divide by another polynomial. And when I say divide by another polynomial, remember that this 1, it would have been dividing by like x minus 1. So that's when I say you're dividing by another polynomial. If you get a remainder of 0, then that you know that the second polynomial is a factor. So if you have a polynomial and you divide by another polynomial and get a remainder of 0, you know for sure you have a factor. And we've talked about this before. If x minus r is a factor, then r is a root. So these are kind of the sort of like 3 theorems that we're learning today. So the remainder theorem says that if you get a remainder of 0, you know that you divided by a factor. And then also the polynomial, the factor theorem says that if you have a factor of a polynomial, then if you have x minus r, then r is the root. So, and I've talked about this a lot, but these are the 2 main things. So you're actually looking for whether or not you have a remainder of 0. Okay, so let's do another example. Making sure I got it on the screen here. All right, so okay, here we go. If I have the polynomial h of x and it equals 2x to the 4th minus 5x cubed minus 11x squared plus 20x plus 12. I'm going to list all of my possible rational roots. And they would be 1, 2, 3, 4, 6, and 12. All over a 1 or a 2. And you can't just leave it like that. You actually have to do more with that. So let me show you what you would do. the possible rational roots, and I'm okay if you just do a plus minus and then parentheses to show all of these could be a positive or a negative. So I have 1 over 1, 1 over 2, 2 over 1, 2 over 2. Well, 2 over 2 is just the same as 1, so I'm not going to write that one down. Then I have 3 over 1 and 3 over 2. I have 4 over 1 and 4 over 2. Well, 4 over 2 is just 2 again. 6 over 1 and 6 over 2, which is just going to be 3. And then I have 12 over 1 and 12 over 2, which is just the 6 here. So you get a lot of redundancy, so you're not going to write all those down. Now, let's do a test with synthetic division. And you just have to kind of start somewhere. So let's just start with the number 1. Sometimes it'll work for you, sometimes it won't. So I'm going to list all of my coefficients. So I have 2, -5, -11, 20, and then 12. Start by bringing down your 2. Multiply, add, multiply, add, and multiply. I feel like I might have done something wrong. 2 times 1, -3. Yes, this should be a -3. So this would be a -8. I'm sorry, -14. And then I multiply that, and I get a -14 here. And here I get a 6. And then here. So I'm not going to end up with a polynomial that is a factor this time. Okay? So let's try another one. So that didn't work. And let me kind of double check, making sure I did all that right. Okay, so let's try the number, how about the number 2? We'll try that one. Now, I want to kind of point out something. A degree of 4 means that I could possibly need to find 2 rational roots to do synthetic division, because I need to get it down from a degree of 4 down to a degree of 3 and then down to a degree of 2. So let's try our 2 here. Bring down your 2, multiply, add. Here I get -13. Here I get a -26. Here I get a -6. Here I get a -12. And here's my 0. So yes, 2 is a root and x minus 2 is a factor. So I can go ahead and start my list of roots. Okay, I could even start my factorization. That's going to be an x minus 2. Now, I want to see if this might be something that could factor. This is 2x cubed minus x minus squared minus 13x minus 6. So no, it doesn't look like something that will factor. So what I'm going to have to do is I'm going to have to keep going, and I'm going to choose one of my other possible rational roots up here. So let me try the number 3. So I'm just going to kind of do something, I call it piggybacking, where once I get something out, I can continue on, because it would also go into this one and get a remainder of 0. So bring down your 2, get a 6 here, here I get 5, 15, here I get 2, here I get 6, and here I get 0. So this is 2x squared plus 5x plus 2. So I know that 3 is a root, and then x minus 3 is a factor. So that's where I'm at so far. Now, what I want to do with this, I want to see if it would factor, and I do believe it does. Okay, now if not, I could do the quadratic formula here. And if you have 2 imaginary or 2 irrational roots, this is when you would find them, right here. You'd have to do the quadratic formula, or you would have to do take square roots of both sides, if it's something that had maybe a 0 right here in the middle. And you're going to explore this tomorrow in a really good activity that we're going to do. So let's just see if we can factor this one. This one is going to factor, and it's going to be 2x and x, and I believe I could do plus 1, and you can factor the 2 here, that'll work. So there's my 4x, and 1x is 5x. So here are my other 2 factors, 2x plus 1, and then I have x plus 2 right here. And my roots are going to be a -1/2 Now, this is an x plus 2, so it's going to have a negative 2. So without even touching the graphing calculator, I have 4 roots, and I have all my factors that are associated with those roots. And guys, it's all about our new theorem today, the rational root theorem, that says I can list out all the possible rational roots and test them, and then the remainder theorem that says if I get a remainder of 0, then I know I'm dividing by one of the factors. And what you're going to do for homework is 1, 4, 5, 6, 7, and 8. Remember, this will be all without the calculator. The first one is just factoring to solve. You really only have, 1 and 4 are factoring to solve. 5, 6, 7, and 8, you're going to use the rational root theorem, and then you're going to use synthetic division to simplify down. Okay, and there's a good chance you'll finish most of this in class. So just making sure 1 and 4 and then 5 through 8 is when you're actually finding all the roots. And that will do it for today's lesson.